Ever pondered about the reason behind the ice ages that have blanketed our planet, not once, not twice, but 5 times? Well, it was a mystery that baffled scientists until the 19th century. The evidence was undeniable. Our Earth had been repeatedly swathed in ice. However, it wasn't just one ice age but 5 distinct ones that we could measure. The energy required to freeze and thaw our planet repeatedly was mind-boggling. So, what could be causing these cycles? Surely it had to be the most potent force on our planet. There were myriad theories, each as grand as the other. Some suggested that uplifting mountain ranges could have altered Earth's winds enough to modify the climate. Others believed that ice was the natural state, disrupted only by massive volcanic eruptions. But none of these theories could explain the cyclical nature of ice ages. And then, in the early 1900s, a Serbian scientist named Milankovic stepped onto the scene with a groundbreaking theory. Milankovic, studying the Earth's position relative to other celestial bodies, discovered a fascinating truth. This Serbian scientist, Milankovic, observed the gravitational pull of the sun and moon and their gentle influence on Earth's motion and tilt. This interaction, he found, led to subtle shifts in Earth's tilt towards the sun. Now imagine a dance, a celestial ballet if you will, where each partner's move influences the other. In this cosmic waltz, sometimes Earth gets a little closer to the sun and sometimes a little further away. These shifts in distance, while seemingly insignificant, can cause our planet to receive a little more or a little less solar radiation than usual. These variations can span tens of thousands of years, with each of Earth's hemispheres experiencing different levels of solar exposure. This solar radiation, or lack thereof, doesn't just give us our seasons, but it also sets the stage for larger climate patterns. It was this cyclical fluctuation in solar radiation that set the stage for the ice ages. Vladimir Koppen, a Russian meteorologist, took Milankovic's work a step further and discovered an intriguing detail. He found that the real culprits behind the ice ages were not the freezing winters as one might expect, but moderately cool summers. Here's how it works. When a summer never gets warm enough to melt the previous winter's snow, you're left with a base of ice. This icy base makes it easier for snow to accumulate the following winter, increasing the odds of snow sticking around in the next summer, which in turn attracts even more accumulation the following winter. In a domino effect, this perpetual snow reflects more of the sun's rays, exacerbating cooling, bringing more snowfall, and so on. Within a few hundred years, a seasonal snowpack can grow into a continental ice sheet. This cycle illustrates how a seemingly small change in conditions can lead to monumental results. The ice ages teach us an invaluable lesson about the power of compounding. Much like the gradual accumulation of snow leading to a massive ice sheet, compounding works on the principle of incremental growth over time. It's about the small changes, the little bits that add up. Each piece serves as a stepping stone for the next, creating a snowball effect that leads to extraordinary results. In the realm of finance, this principle applies beautifully. A small investment today, steadily growing and reinvested, can lead to a mountain of wealth in the future. It's not about the size of your starting base, but the power of consistent growth and time. This is the magic of compounding. Slow and steady growth that, over time, leads to something monumental. And just like the ice ages, the power of compounding in finance can lead to results that seem to defy logic, underscoring the importance of understanding where growth comes from and what it can lead to.